Hello people. In the last module we discussed about the system equilibrium, and in this module we will be taking an example and we'll try to calculate the forces which are acting on a system of particle to find out the static equilibrium equations. Okay, so let's go for the example. So this is the typical example I have taken from a book. So in this example you can see there is a man which is trying to pull a rope, which he is applying a tension in this rope, and this rope is passing over several pulleys. Okay, so when this rope is, and there are two separate weights whose values are known to us, and which is always known to us that W2 is greater than W1. That means that weight number 2, which is not mentioned here properly, is greater than weight number 1. So we will try to find out the system equilibrium in this condition. Okay, so for this we will take few assumptions. We will make few assumptions and we'll assume frictionless bearings. The bearings are frictionless. We'll assume the tension in the cable, belt and rope is same throughout, and we'll definitely neglect the pulley weight. We always make those assumptions to make our calculation simple. Okay, so as in this case we already discussed about the system equilibrium as the balance of force in both directions, x and y. So since we don't have any forces in x direction, we'll go for the equation as sum of forces in the y direction is equal to 0. Now we can take any pulley and we can use the system of equilibrium equations. So we'll find out the system of equilibrium for this pulley P1. So summation Fy equals to 0 for P1. Okay, so this is the pulley. If you see at the right hand side here, there is a tension in the rope which is W1 and which is same as on the left side. So this W1 is again on the left side. If you see in this rope, which is the center rope, which is actually the tension applied by this man. Okay, so this tension can be T2, and this is the result we want. We want to find out how much tension this man should apply so that the system remains in equilibrium. So we want to get the value of T2, and this is a fixed support that is offering some tension, that is suppose T3. So if you take the positive y-axis as positive direction, we can take any sign convention, but say positive y is plus for us, so we'll write here as T3, which is left side, as positive, W1 is negative, minus T2 as negative, minus W1 as negative, that all equals to 0. So we'll finally reach to a conclusion that T3 equals to 2W1 plus T2, and that you can see here. Okay, so T3 equals to 2W1 plus T2. So that is one set of equations, but in these equations we have the value of W1 only, and we have two unknowns, that is T3 and T2. That means we have one equation and two unknowns. Okay, so that is not what we want. So for this we have multiple pulleys. We'll try to balance, try to use the system of equilibrium equations for another pulley, that suppose P2 in this case we take. So for P2, this is pulley P2. For P2 there is a weight tension T2 is coming in right hand side from top. This T2 is again going to the left. There is a rope which is carrying a W1 load in the center of the pulley, and there is a load W2 on the downside. Take any sign convention, whether positive or negative, that answer will be same. So I'm taking upside as positive, and I will get T2 plus T2 plus W1 is equal to W2. With